Hey, hi, I'm Ramya, Embedded Software Engineer at Microsoft Technologies. Welcome back to my channel. In today's video, I'm going to show you a very interesting project where we integrate artificial intelligence with embedded system. So the project title is Rainfall Monitoring Application using AI on Cortex-M4. So now normally in embedded projects, if rain is detected, we simply turn on a buzzer using an if condition. But in this project, instead of hard coding condition, we are using AI to intelligently decide the alert behavior dynamically. So this becomes an AI powered embedded monitoring system. Traditionally, rainfall monitoring systems are very basic. They work like if rain is detected, then buzzer should be on, else the buzzer should be off. That's it. But there is no intelligence, no adaptation, and no learning. But in real world smart systems, rainfall intensity changes, weather condition changes, alert severity should also change dynamically. For example, light drizzle may need a small alert. Heavy rain may require stronger alerts. Weather temperature may affect rainfall behavior. So, instead of fixed conditions, we use AI to make intelligent decisions. The main objective of this project is to monitor rainfall conditions, use live weather data, integrate AI with Cortex, and generate intelligent buzzer alerts dynamically. We also implement live data logging, automatic AI retraining, continuous learning, so the system keeps improving over time. Okay, let's see what is TDCA first. So TDCA is Target Device Communication Interface. The AppCOE application on the left side, and the right side should be your target hardware. So whatever the program you're doing on your AppCOE, and that is sent as a command to the target hardware. So target hardware receives the command and send the response back to the host application via the serial communication. This target hardware receive the command from the host and execute them and then send response back to the host. So this is the TDCA architecture. So just imagine whatever the command comes from the host, the target is simply respond for the command just like a master slave. So this is how the TDCA architecture should look like. So let's see the overview of this project. So this system actually continuously monitors the rainfall conditions. So here you are using a rain sensor. So that is sending a data to the Python AI model. Then it analyzes the rainfall intensity with the live weather information like temperature. Based on the AI prediction, based on that AI decides how many times the buzzer should beep to indicate the rainfall severity. So that we should know that if the rainfall should be mild, then very less beep is enough. If the intensity of the rain should be more, then the beep should require more, so that we can strongly alert the people about the rainfall. Now let's see the hardware and software components used in this project. Python AI model and a log file, rain sensor, Cortex microcontroller, buzzer. Let's talk about the machine learning part. In this project, we use some decision tree regressor. So the model is trained using historical data like rain value, temperature, and week count. So based on the rain value, we're getting a live temperature data from the website, and then based on that, AI will keep the beep count. So the AI learns how rainfall intensity affects the alerts, how weather affects the behavior, and predicts the intelligent outputs. This is the one of the most important concepts in this project. After several samples, the system automatically retrained the AI model. So the model continuously improves using live sensor data. This is called continuous learning AI system. So this makes the project much more advanced than traditional embedded system. So after using this trained value, so AI can decide itself that for the particular rain value and along with the temperature, it will decide how much beep count should be given. So that is what this project should be. What makes this project special? The special thing about this project is we are not simply reading the sensors, we are integrating embedded systems with AI using live internet weather data and performing the machine learning predictions, retraining models dynamically, and creating a continuously learning intelligent system. So this is the future direction of embedded system and an AI. Okay, coming to this coding part, you should include TDCI.h for using TDCI API call, and here this OS application start is just like your main function. Inside that you should write your code, and before that you should initialize with your COM port using TDCI init, so that the serial communication will be happen between the host and the target hardware. And then the following code you should write. So STM32 calls the Python script using a system, receives the rain sensor value and the city name. Then the Python fetch the live weather data. So that is, you can see here after getting the city name. For example, it gives you a temperature or cloud percentage, humidity, whatever you needed. So those weather data you will get from a live open weather website. Then the Python load this trained machine learning model. Then this model predict the number of buzzer alerts. And then this prediction will be saved into the prediction.txt file. So here only you're going to get the last predicted value, and then all your sensor log should be saved under .csv file. So the beginning you can see, or the training values you provided to the AI. After that, AI will give the log with his decision. The model is trained using this using historical data like this. So here we are using a decision tree regressor, so that you're going to see the data log like this. So the system continuously log the live data into a .csv file. After several samples, the system automatically retrains the AI model. So the model continuously improves using a live sensor data. So this is called a continuous learning AI system. So after the prediction will happen, it will stored on the prediction.txt, and then you'll get stored on the sensor log.csv file. After that, the AI get retrained after few samples, and then it will decide the beep count of the buzzer. So this is how the AI based rainfall monitoring should work. Now I'm going to run this project. So can you see I'm just getting the command. The target board should be the ST board. I'm getting received response from the board, and then I'm setting the input output pins, and my ADC channel is start going to read. So rain sensor is the analog sensor actually I'm using here to take the ADC value, and the param value here I'm getting without rain condition. To get the ADC value, it should start the ADC, and then pole conversion should happen, and then it will start reading the sensor for calling this ADC get value API call. See, I am getting a live temperature for Munnar is 16 degrees Celsius right now. There is no rainfall, and the weather condition should be 16 degrees Celsius. And then the prediction should be, you can see the rain value, temperature, and beep should be heavier 4 times. So as per that, you can see the buzzer pin should on and off after some delay. So the buzzer should be on and off for 4 times with particular delay. Now I am going to detect the sensor. Can you see I am getting a param value should be 72, which means I am getting some mild rain, and the temperature of Munnar should be 16 degrees Celsius, and I am going to get the beep should be 1 time. So based on my rain sensor value, I am getting a beep as a 1 time. For that, you can see the buzzer should be on and off with a small delay. So this is how the AI going to train you based on the sensor value. The beep code should be either increased or decreased. Okay, coming to this hardware demo, here I'm using a Cortex board and then rain sensor. For alert system I'm using a buzzer. So I gave all the required connection between the board and the sensor and output devices. So now I'm going to run this project. So I started running this project. Initially I'm not detecting anything on the rain sensor. There is no rain detection. So with that, the rain sensor value should be high. Meanwhile, it will detect the live weather data with the help of AI. So you will get the beep alarm sound. For the 4 times you will get. After few delay, it will again beep. So like this you will see as a 4 time. So next I am going to show you with the rain detection. I am just detecting some water droplets on the rain sensor. So this is how, based on the rain intensity, you can control the alarm with number of beep sound. So this is purely taken a decision by the AI with our trained inputs. So initially you have to give some trained sample inputs to the AI. Based on that, AI will take the samples. After that, it will decide whether how many beep count should required based on the rain intensity. I hope you like this project. Thank you for watching. And if you found this video helpful, please follow us and leave your questions or comments below, and stay tuned for more innovative embedded projects. Bye.